Hey everybody, Mr. Elliott here. Um, Today's not a good day for me. I actually taped this lesson once during lunch and it was about a 20-minute lesson, but the first example ended up being really bad and really ugly, and it really disrupted the lesson. And then there was some dead time as I had to make a quality third example. So anyway, I'm remaking this lesson. Let's take a look at it. Hopefully you've gotten comfortable with completing the square both when a is equal to 1 and a is not equal to 1. So we can turn our focus now to, if I give you some information about a graph, we need to write an equation, all three equations for this situation and draw a complete graph. By the three equations, there's standard form, which looks like y equals ax squared plus bx plus c. There was vertex form, which was y equals a parentheses x minus h quantity squared plus k. And then there's also factored form, which was y equals a parentheses x minus c1 and x minus c2. And draw a complete graph. These are kind of long problems. So, vertex, because they're giving me the vertex here, it'd be a good idea to start off using vertex form of the equation. So, I start off by writing out the equation, y equals a parentheses x minus h quantity squared plus k. And the vertex, these are my h and k values, and the point is my x and y values. So I'm going to take these points, plug it all into the equation. So the y becomes 15, then this a, the x becomes a 1, the h is a 3, and the k is a negative 5. Let's see, I add this 5 to both sides, so it becomes 20, and over here 1 minus 3, that's negative 2. Negative 2 squared is positive 4, so I get 4a. And then when I divide both sides by 4, I get a equals 5. So the vertex form of my equation is y equals a, x minus the x coordinate of the vertex squared, and then minus or plus the k, but in this case the k is negative, so minus 5. And oops, Ellie forgot to write 5 for a, my mistake. So 5 parentheses x minus 3 quantity squared minus 5. Okay, so that's vertex form. Next I'm going to transition into standard form, and I can do standard by going 5 parentheses x minus 3 quantity squared minus 5. When you, oops, there's no squared, x minus 3 squared becomes x minus 3 times x minus 3. So when you FOIL all this together, you get x squared minus 6x plus 9. And I still have this minus 5 out here. And I end up with 5x squared minus 30x plus 45 minus 5. And then you can add the 45 and the negative 5 together, and you end up with 5x squared minus 30x plus 40. And that's standard form. And then you can work from standard form to factored form just by factoring. So on this one, these all have a 5 in common. So you'd factor out the 5. What's left on the inside is x squared minus 6x plus 8. And this ends up becoming 5 parentheses. And this multiplies to positive 8, yet adds up to negative 6, x minus 2, and x minus 4. And that's my factored form. And now, using these three equations, each equation actually gives me some nice information about the graph that I can put into my complete graph. It's a positive x squared equation. So I end up with something like this. The vertex, I know from my vertex form, is at 3, negative 5. And at the same time, that line of symmetry is going to pass straight through the vertex, and it's a vertical line, so it's an x equals, in this case, x equals 3. Factored form gives me the x-intercepts. If I set x minus 2 equal to 0, I get 2. If I set x minus 4 equal to 0, I get 4. So that means that I have a solution here at 2, 0. Or not a solution, but an x-intercept, and another x-intercept at 4, 0. Then lastly, you need the y-intercept. Well, the y-intercept is when x is 0, and standard form is an easy equation to work with. If you plug 0 into this equation, out pops 40. So that means that this point right here is 0, 40. And that's my complete graph. Suppose you are a horrible grapher. Not a horrible grapher. Suppose you are a horrible factorer. So you're able to do this to get to your vertex form, and then you're comfortable getting down to here. But now let's say that you're a weak factorer, so you're not sure that you can make it to factored form. There's another solution. There's another way you could do that. That would be when the you get the x-intercepts when y is equal to 0. So if I took my vertex form equation and I set y equal to 0, so 5 parentheses x minus 3 quantity squared minus 5, and then algebraically solve for x. So first I could add 5 to both sides. I want to square root, but I can't square root until I divide both sides by 5, so I get 1 equals x minus 3 quantity squared. I can then square root both sides. When I square root both sides, square root of 1 is 1. But you got to remember to put in that positive negative. So positive negative 1 equals x minus 3. When you add 3 to both sides, x equals 1 plus 3, which is 4, and negative 1 plus 3, which is 2. So my x-intercepts are 2 and 4. That helps me with that graph because that gives me the point 2, 0, and 4, 0. But then if I wanted to go from here directly into factored form, I could. I already know that my a term is 5 because that never changes between the 3 forms. And then it's just if factored form, x minus c1 and x minus c2, and those c's are 4 and 2. So x minus 4 and x minus 2. So I algebraically solved this. That got me to here, and that told me what the x-intercepts are, which allowed me to get into factored form. So a backdoor way to factoring in a problem like this if you do not know how to factor. That could be handy. That's example 1. It might be noted, I wouldn't actually normally solve it this way. I would normally just factor it, but for people that can't factor, this is an alternate technique for you. All right, Elliot has one more example for you. For this one, number 2, they're telling us that the roots, the roots are x equals 3 and x equals negative 5, and that it passes through the point 1, negative 24. Now, first of all, roots. What do they mean by roots? Roots are the exact same thing as x-intercepts. So they're telling us that the x-intercepts are 3 and negative 5, which means in this case it makes most sense to start in factored form. So it's going to be y equals a parentheses x minus c1 and x minus c2. And 3 is my c1, negative 5 is my c2, and then this is going to be my x and my y coordinate. So I plug in negative 24 for the y, a. For x I'm going to plug in 1, minus c1, and then x is 1 plus 5, because it's a negative 5, so I put a plus 5. All right, negative 24 equals a times negative 2 times 6. This becomes negative 2 times 6 is negative 12. So negative 12a equals negative 24, which means a is equal to 2. So my factored form equation is y equals 2 parentheses x minus the first constant and x minus the second constant. So that's my factored form. Next form would be working into standard form. So I'd start off by foiling these two together. X times x is x squared. Outers is 5x. Inners is a negative 3x. 5x minus 3x, that's 2x. So plus 2x. And then negative 3 and 5 is negative 15. And then distribute the 2, and I end up getting 2x squared plus 4x minus 30. Standard form. Okay, now I work from standard form into vertex form, and I'm also going to show you two techniques for doing this, just like the last example. The first example is the math teacher and me talking. The math teacher me says that when you're in standard form, you get to vertex form by completing the square. So, as I've done in my previous lessons, I factor the 2 out of these first two terms. So I get 2 parentheses x squared plus 2x, and I keep this as this negative 30. And then as I've done before, x squared plus 2x plus some number. 2 divided by 1 is 1. 1 squared is 1, so I'm just going to add a 1. On the outside, I need to subtract whatever I just added, but you got to be careful. You didn't just add 1. 2 times 1 is 2. So on the outside, I need to go minus 2, and then continue on with this minus 30, or minus 30 that was there originally. Then, x squared plus 2x plus 1 becomes x plus 1 quantity squared. Negative 2 and negative 30 is negative 32, and I am in vertex form. Okay. Backdoor way. Actually, I'm going to give you two backdoor ways to do the same thing. I'm going to start actually by getting this graph started. I know that my roots are positive 3 and negative 5, so I'm going to start off by writing my x-intercepts in my graph. So negative 5, 0, and 3, 0. Now, we talked that earlier that the vertex is always in the middle, the average of the x-intercepts. So if I take negative 5 plus 3 and divide it by 2, that gives me negative 1. That means that this x-coordinate's negative 1, and then I could just plug negative 1 into any old equation, and I could get what that value is. And I'll plug it into this first one. So 2 negative 1 squared plus 4 times negative 1 minus 30. So I end up getting, that's 1 times 2 is 2, minus 4 minus 30, which ends up being negative 32. So while the x-coordinate's negative 1, the y-coordinate's negative 32. Which is really the same way I did, if you looked at this, negative 1, negative 32. Third way, I talked about going negative b over 2a if you have standard form. If I did that, the x equals that. So negative b, so negative 4 all over 2a, so 2 times 2, which is negative 1. So the x-coordinate's negative 1, just like we came up with earlier. And then if I plug negative 1 into the equation, out pops negative 32. So negative 1, negative 32. A lot of different ways to find the vertex depending on what form you're in. Last thing, mark up where the y-intercept is. That is that if I look at this form here, if I plug in 0, out pops negative 30. So at 0, negative 30 is a coordinate. And that's the last bit I need to put in, minus the line of symmetry. I always forget about the line of symmetry, as do students. Don't forget about the line of symmetry. And that's it, students. That's all I have for you today. So purpose of this lesson was, just getting comfortable with moving between like all these different forms, and then at the same time, like you can use different forms to help you find different pieces of information. Anyway, I hope this was helpful for you. These two examples are meant to help you out with the bottom of finding and of completing the square and finding equations worksheet. And that's what we're going to work on in class on Friday, and I hope you have yourselves a great day. Bye-bye.